So let me just print that. Let me just print the head of it so that we can actually see what we are doing over here. All right, so we have the class, which is our target, all right, which is a dependent variable, right, and then the rest of them, which are, independent columns. All right, so we're going to separate them into dependent and independent. All right, so let's do this. So instead of maybe picking them one by one, we can just drop the class column, which is the dependent column. You can just drop that column. All right, so that we will be left with the rest. So we specify that it's in the column, right? So axis equals 1. All right, and then after dropping it, we can actually put that only that one in Y, which becomes our dependent column, right? So we select only that. Okay, so now done. Now what we are going to actually do over here is to use the train test split, which is present in the model selection, which is in the scikit-learn library. All right, so we're going to use that. So first, let's import that. So from sklearn, all right, sklearn.model selection. You're going to import what is called the train _test _split. All right, so we're going to use this train test split to actually split our data set into training and testing data. All right, we're going to use that. So in this case, we're actually going to split our data into, so let me write this comment here. All right, we're going to split our data set into 70 into 70-30 ratio, right, where we use 70 for training and then we use a 30 for testing. This, you can use say 80. You can use 80. All right, we can use 80 and then maybe 20 for testing, right? 80 for training and 20 for testing. All right, in this kind of small data set, let's use something like this. Okay, this one will work for us. And then after splitting it, we are going to save the training. We're going to save the training in X, what is called the X train. All right, we're going to save it in the variable called S train, and then the testing. All right, remember we've separated our data into X and then Y. All right, so those in X that will be going into the training, we store it in a variable called X train, and those in X that will be going into testing, we store it in what is called the X test. All right, and those in Y that will be going to training, we store it in what is called the Y train, and those in Y that will go into testing, we store it in what is called the Y test. Okay, now here we're going to use the the train test split, all right, to split it in the ratio of 70-30. All right, we're going to use it to split our X that we our X that we have here, and then our Y that we have over here. All right, so we're going to use that, and then we will actually specify that the test size, we want the test size to be 30%, so you can use 0.30 or maybe 0.30, visually better. Let me squeeze this a bit here. And then we can also set a random state, random_state. All right, we can set it to just a number, any number like that, because if we see what we are doing for random states here to be 1 is that if we don't set this, anytime we run this, we're going to have different random numbers being generated from this that we have, this X that we have and this Y that we have. All right, whatever 70-30 that we have here is going to be generated randomly, and if we don't specify the random state, then each time you run this this notebook, it's going to actually generate different random numbers for us, and we're going to have different outcomes. But we want consistency here. All right, that's why we set random state, so that anytime we run it, we will still be having the same output. We will not be actually be generating different random numbers at different times. All right, so let's run that. There's something else we have to do. Random states. Okay, then I think there's train test split function being here. Okay, this one, that's it. Okay, so now we can actually start to build our algorithm. So the first one that we will start to build is the KeyNearest Neighbor. All right, so we will start with K. Let me do it like this. KNeighbors classifier. All right, so we start with KNeighbors classifier. Convert this to a markdown. Okay, so in order to start using this one, we can actually get the KNeighbors classifier from the neighbors package, which is present in the scikit-learn library. All right, so from scikit-learn, right, from sklearn dot neighbors, you're going to import what is called the KNeighbors classifier. All right, so let's run this and see. Okay, I think there's some spelling error here. Yeah. Done. Okay, so now we can initialize this. All right, let me use maybe caps so that it will not conflict with the inbuilt functions. Okay, so now we can initialize this. So we've imported our classifier, our KNearest classifier. Now we can initialize this and then specify the number of neighbors. Okay, in this case, I'll just set it to 5, and you have to note that this number of neighbors is not just randomly chosen. All right, it has to be carefully chosen, otherwise you end up building different algorithms if you choose different weights. Yeah, choosing different number of different neighbors. All right, and I'll show you the best way of choosing this. All right, in the doubt session, I'll show you the best way of choosing this. All right, I'll show you how to choose this. It's not just being chosen randomly. There's a way of doing this and getting the right right neighbors. Okay, so let's move on. Let's move on by starting to let our variable that we created here. All right, we initialize it. So this is actually going to be our model, right? So what we are going to do is we're going to let our model to learn. So KNN.fit, all right, to learn from what? To learn from the X train, all right, to learn from the X train, that is the training data, and then the Y train, which is the Y train data. Remember, we divided our data set into X and Y. So those that are in X and those that are in Y, that we are saying that they should actually be a training data set. Remember, we said 70-30, right? So we have 70 for training and then 30 for testing. So those that are in training, we are using it to train. So this is when our machine learns. So that's why we say machine learning. This is where our machine learns. If you start by saying that your model to fit, all right, to learn from what? To learn from the training data. All right, so this is when our machine learns. Okay, so now if we run this, now our machine has learned, it has actually learned from these data that we have fed with this. All right, so now from here we can actually use this has actually become our model. This is just a name that I chose. I could have also named it as a model, right? Or maybe algorithm. All right, we could have also named it like that. All right, so I just chose it like KNN because we are going to build two different algorithms, so that I'll be able to just identify which one is which algorithm is KNN algorithm and which one is support vector algorithm. Okay, if it's supposed to be just a one model that I'm building here, then I would have just chosen maybe a variable called model or something like that. So it's just a name that you use, but after that it's actually going to learn from the data. All right, so now the KNN here is our model. All right, this is all that the hospital is looking for, that this model can actually make predictions. Okay, after learning from the given data. Okay, so now let's see if it can actually make some predictions. So let's use the predict, and maybe we can even store these predictions. So let me just make it predicted 1, so that I can also use predicted 2 for support vector machine. All right, so after making the prediction, I'm going to store it in that. So let's see if it can make predictions. So I'm going to use .predict. All right, then remember we divide our data set into two. One that the model will learn from, and then the other one that it will not see it, right? But actually we are going to use that to make predictions so that we can verify to see how effective our model is doing. All right, so here we are going to use KNN.predict. All right, and predict, we are going to use the X text which our data has not seen. Okay, and then we store it in this variable. Okay, so after that I'll print the variable. Now you can see that we are now making some predictions over here. All right, so we're predicting some 2 which represent benign, and then printing some 4 which represent malignant. All right, if we see the data that we fed, so this KNN is just our algorithm, right? And that is what the hospital needs, right? This is what they will pay you to do. These are the algorithms that the company will pay you to do. Okay, so now let's see which test that we fed with this. Now, if you give them this algorithm and then new cell comes in, right? They compile maybe some 2 or 3 other cells. All right, they will now feed that cell information into this algorithm that you've built, and then start to make some predictions. All right, so maybe a cell comes in, and then this algorithm is able to predict the cell as 2, meaning that the cell is benign, is not cancerous. Or maybe the algorithm will predict it as 4, as malignant. All right, so this is the data set that we fed into it. It's having a lot of column attributes here. All right, so our data will use this information to predict based on the information that it has already learned. Okay, so let me take this one out. Now let's move on and then build, or maybe we can check the score before we build the support vector machine. Let's check the score for this one. So from scipy.stats, we can actually import z-score. We can import z-score, and then we will print this is KNN, right? So I'll just print KNN class. Let me just copy this one. Algorithm is predicting at okay, so at let me just do this, and then over here I'll do the KNN. Oh, come on. Okay, I'll do KNN, then I'll check the score of it. I'll check the score of how it is doing on the X test. And also on the Y test. So I'm checking the score of how our model is actually doing on the X test and then the Y test. All right, let's test. Oh, come on. It's missing one additional argument. Okay. Let's go. End of this. Okay, so we have KNN. We need one more here. Okay. KNN.score, then we will have this. Let me see which one we are missing over here. Okay, let me just do this one again so that I'll just get it. So I mean KNN score, and then in that I'll use X underscore test, then I'll use Y underscore test. All right. Okay, so now it's good. Let me just convert it into
it's 2 o'clock.
Okay, so now we can see that it's doing like 97%. Let me just shorten this. So I can do this. And then add the percentage sign here. Let me see. Okay, now good. So I can do dot format. Great. Now you can see now it's a bit intuitive here. All right. So now you can see that our model, or KNN model, is now doing 97%. All right. So let's now move on to do support vector machine. All right. So I'll do support vector machine. All right. So let me convert this to markdown. Probably increase it a bit. Okay. So for support vector machine, we're going to use what is called the SVC, right? Support vector classifier. So from scikit-learn, right? From sklearn, we are going to import what is called the SVC. Okay, and then we will start to initialize it. So this one becomes the algorithm that we're going to be. Remember, the other one I just use KNN just to identify it. So in this case, I'm going to use SVC so that I can identify my algorithm. All right, so I'm going to initialize this, and then after that, I'll use my SVC to learn, right, to fit the data. To fit what? To fit the X string. All right, so it is going to actually learn from the X string, and then it will learn from the Y string. All right, so let's run this and then see what happens. Cannot import name SVC from scikit-learn. Okay. it should rather import it from SVM. Okay, now it's good. Now it's giving us setting warning to set gamma explicitly, blah 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 blah. So these are some changes in Python 3.7. Let me set gamma. Let me set it to say 0.025. All right, then set C. Just set C to 3. All right, good. Now over here we can actually use this. So now our SVC has actually learned from this training data just as our KeyNearest Neighbor algorithm learned from the same data. All right, and then made some predictions over here. So now we are going to use our SVC to also make predictions. All right, so we have our SVC algorithm that we have built. We use it to make predictions. So let's store it over here. We store the predictions into predicted_1. Okay, so over here we're going to store it into predicted_2, and then we use our SVC algorithm to make some predictions. All right, so dot predicts. All right, and then make predictions from the X test. Okay, then after that I'll just print it. Okay, now you can see it is actually making some predictions here. All right, predicting some 2, which is representing benign, and predicting some malignant here. Okay, so now we can also check the score just like we did for KNN. All right, so I'm going to use this one and then change the KNN algorithm to SVC algorithm over here. All right, so this one is not KNN. This is support vector. All right, this is support vector algorithm is predicting at. Then I'll change the algorithm here, SVC. Now if I run it, now you can see that this one is actually doing at 98%. All right, as compared to the KNN, which is performing at 97. All right, which is performing at 97. Okay, so now we can actually do some what is called before we even do the confusion matrix, we can compare these predictions. All right, we can compare these predictions. So let's try and then do that. Let's try and then do that. So let me first convert these predictions into a data frame, since it's just some a list. All right, let me convert these predictions, each of them for SVC and then for KNN. All right, let me convert each of them into a data frame so that we can compare them side by side. Okay, so we have KNN. We use this KNN predictions. Then I'll use this PD dot. Is it even necessary to write PD dot? And then the first one was this. No. Okay, so this is the first one for KNN. All right, this is for KNN predictions. So we're going to do the same thing for SVC predictions. SVC, and then that one was the predictions were stored in predictor 2. All right, so now let's convert these two. Then after that we can actually put them together. All right, let's store them in what is called df1, and then we can concat, that is putting them together. Right, concatenate them. So we're going to concatenate these two. Okay, now if we check df1, okay, now it has been put one under, one is under the other, right? But we want to see it side by side, so let's specify as x equals 1, and then run this df1 again. Okay, now you can see that it's been put side by side, right? With it's just giving us some auto columns here. I can just change that one. I can just specify a column df1 dot columns. All right, equals to, then I'll just use their names to represent the columns. SVC. All right, now if I check df1, okay, now it's better. All right, so we have these are the KNN predictions, and this part is the SVC prediction. So we can now see those that KNN is predicting to be benign. It's the same thing. SVC is also predicting to be benign. All right, so you can actually go this KNN predicted 2, SVC predicted 2, KNN predicted 4, SVC predicted 4. The same way you can see for all the others, all right? And I think there's somewhere that KNN was making a little bit of mistake of predictions as compared to SVC. That's why SVC is actually performing at 98 as compared to KNN, which is performing at 97. But they are all quite good, all right? Quite good and quite, quite matching each other. All right, so we can now actually see the classification report for each of them. So for building the classification report to actually see how they are doing, to further see how they are doing, we are going to import the matrix. We are going to import matrix from scikit-learn. All right, so from scikit-learn we're going to import this, what is called the classification. All right, the classification report. All right, we're going to import this classification report. Okay, classification. Okay, done. And then after that we will use this classification report. Let me just copy that. We use this classification report, and then we'll do this one for KNN. All right, so for the right test here, and then the predictions were stored in what is called the predicted _1 for KNN. All right, _1. You can see here. So let me just make it a little bit intuitive here. Okay, this is a bit better to see. All right, so let me write this so that we see that this is for KNN. So this is KNN classification report. Okay, it's a bit put together, putting the KNN together. So let me just copy this here, put it here. Okay, let me just duplicate it 10 times. Okay, now we have a line here to separate it. Okay, now we can actually see, let me do the same thing for KNN, for SVC, and then we can compare the two. Okay, so this one is SVC, all right, and that was predicted too. Okay, now if we compare the two, right, if we compare the classification report for the two, now for precision, right, what precision is saying that for all those that are benign, right, all those that are 2, that's after building our model, all those two, how correctly we were able to identify 2 as 2 and how correctly we were able to identify 4 as 4. So if you see the precision for KNN, all right, precision for KNN, we can see that at 96% we're able to identify 2 as 2, and at 99% we're able to identify 4 as 4. The same way, if we come here to the SVC, we can see that at 99% we're able to identify 2 as 2. At 97% we're able to identify 4 as 4. All right, and then the recall for the number of the 2s that we're able to identify as 2, how true is how true are we able to, our algorithm is able to recall or remember that 2 is actually 2 and 4 is actually 4. All right, so at 99% we're able to recall 2 as 2, and then at 97% we're able to recall 4 as 4, as compared to that of KNN, where 99% of the time we're able to recall 2 as 2, and then 93% we're able to recall 4 as 4. F1 score is a combination of precision and recall, and if you can see here, we have 98% of that for 2. F1 score for 4 as 96% as compared to 99 and 97. All right, so we can see that our SVC is quite doing a bit better than in KNN. All right, so let's see the heat map of both of them, the confusion matrix for both of them, and then we can actually make further judgment on the 2 algorithm. All right, so for that we are going to start by importing what is called, we have already imported matrix over here, right? Okay, let me just do it here, sklearn. So this is the reason why earlier when I told you can just use PyForest instead of typing these libraries over and over again. You could have just used PyForest to just do that. All right, so let me just print over here as confusion matrix for KNN. All right, confusion matrix for KNN, and then let me just confusion matrix CM, and then I'll use matrix dot confusion matrix dot confusion underscore matrix. All right, and then I'll use the S test, S underscore test, and I'll use the predicted one. This is for KNN, right? So predicted one, we stored our predictions in predicted one. All right, and then the labels, we have 2 and then 4. All right, so let me do a data frame for the confusion matrix. This indentation is not supposed to be there. Okay, now let me do a data frame for this confusion matrix. Okay, so I'm going to put the confusion matrix in here, and then I'll set the index. Okay, let me do it like this for I for I in sorry, I for I in 2 and then 4. All right, then I'll specify columns for here. Okay, so I'll use predicted so that I'll get to know which ones I predicted, and or maybe I should just use predict. So I'll use predict benign, and then I'll use predict I'll use predict malignant. Okay, so now I can set a figure size here, so plt dot figure, and then I'll set fixed size. Let me give this one to be say 7.5. All right, 7.5 will do. And then in Seaborn, I'm going to use the heat map. Then I'll put the data frame that I created, which is df_cm. All right, then I want the annotation to be on so that I can actually see the values that were predicted right and those that were predicted wrong. Okay, let's see this. Confusion metric has no attribute confusion metrics. Okay, fine. Where is it? From cm.metrics confusion metrics. Okay, so somewhere here. Let me go down a bit so that I can see it. So matrix dot confusion, and then come on, this is supposed to be like this. Matrix. Okay, good. Now we can actually see. Let me plot the so I'm going to copy the same one. Once we've written it for, I don't need the library. Once we've written it for one, I can duplicate it for the other. All right, so this one, it will be for, so it will be a confusion matrix for SVC. For SVC. All right. And then I'll use predicted 2. Okay, so that's it. That's the only thing that I'll change. Okay, so now let me zoom out a bit so that we can see the 2. Okay, so now if you can see here, right, you can see here the 2, which represent benign, we're able to wrongly classify only one, right? The dark part, right? The dark boxes are the wrongly classified ones, all right? So if you see the 2, only one was being wrongly classified, and for the 4, only 5 were wrongly classified, right? So 4 represent malignant. Right, so 68%, 68 of them were correctly classified or identified or recalled as malignant. All right, sorry, we were able to predict 68 of them as malignant, and only 5 wrongly. If you see this one here, we were able to predict malignant, 71 of them, with only 2 wrongly classified as benign, whilst it was supposed to actually be malignant. All right, with only two mistakes here for benign, only 2 were wrongly classified. All right, so our model is actually doing great. It's actually doing great. If you see the dark section is very less, only 2 and 2 here, and then here 1 and then 5. Okay, so we can actually infer from this and then see that SVC is actually doing quite better, right? Doing quite better. It's actually if you see the benign, this one made only 1 mistake, this one made 2 mistakes, but if you can see for the malignant, right, for the malignant, it was able to predict 71 of them correctly with only 2 mistakes, whilst KNN was able to predict 68 of them correctly with 5 wrongly. Okay, so now in this case we can actually say that we will move ahead with our SVC model. All right, so we will use SVC in production. We are going to recommend that to Dr. William. So if a new data comes in now, they don't actually need to do this manually. They can just use our SVM machine learning algorithm that we've built here to make predictions. All right, so now this SVM is all they need. All right, this SVM variable or the model that we've created here is all they need. All right, so this is the algorithm, and that's what they will use to make the prediction, and this is what we are going to recommend for Dr. William and the entire University of Wisconsin Hospital to be using to make further predictions of any cell that will come in, to be able to classify that cell as either malignant or benign. All right, so thank you for sticking with me. Have a nice day. See you in the next project. Bye bye.